Hey everybody, welcome back to the Physics Bunker. I'm Mr. Voppel. Remember in our last video we saw what happens to an object when the forces are balanced? Well, what happens to an object when the forces are unbalanced? We'll see. Check it out. Pause the video and grab your Level 1 Mission 4 sheet from Google Classroom. I want you to fill it out as you watch. Ready? Here we go. So this is the same cart from the last video. It's still got 2 newtons of weight pulling right here and 2 newtons of weight pulling right here. So what we found out is that this cart is in equilibrium. Left forces equal right forces and up forces equal down forces, which means that this cart will either remain at rest or it will move in a straight line at a constant speed because it's in equilibrium. Well, what if instead of leaving it in equilibrium, I take this 1 newton weight right here and I add it to this side? What's going to happen? Well, here's our cart, and like I said, now it's got 3 newtons of weight pulling to the left. And so what I want you to do is I want you to draw a free body diagram of this cart for when I let go. Pause the video and draw a free body diagram of the cart after I let go. That means nothing is touching it but the track and the 2 strings. Now once you've done that, I want you to tell me the direction and amount of net force. For instance, you would say there's 6 newtons to the right is the net force, or 2 newtons to the left. Tell me, but to prove your answer, use a net force equation for the horizontal direction. Now I want you to predict what you think is going to happen when I let go of this cart. Which direction will it move? And will it speed up, slow down, move with constant speed, or will it not move at all? Will it remain at rest? And to do that, I want you to draw a velocity time graph to predict what the motion of this object will look like when I let go. And for your help, I'm going to put the motion detector right here on this side, and I'm going to let go. So you draw a velocity time graph to predict what you think is going to happen. Pause the video and predict what the velocity time graph will look like after I let go of the cart. Remember, the detector is on the right side of the cart. So here you can see we've got our velocity time graph side by side with the video. Velocity again is going to be measured in meters per second. That's the speed. And then the time is going to be measured in seconds here on the horizontal axis. So let's hit play and see if your prediction was correct. So it sped up away from the detector. Did you get that right? It did not move with constant speed. And it definitely did not slow down. And it definitely didn't stay at rest. It sped up away from the detector. We can tell because the velocity time graph gets further and further from 0 above the horizontal axis. And does that make any sense? Of course, because what direction is the net force? Well, net force at the beginning is to the left, because left forces are greater than right forces. If the net force is to the left, what direction is the acceleration? It's in the same direction as the net force, to the left. So this object, which is starting at rest, has the acceleration to the left. So it's going to speed up to the left because it's in the direction of motion, which is why we see the cart speed up. And if you're wondering why the graph goes back down at the end, well, that's just because the cart hits the pulley and comes to rest at the end. Now that we got that one, I'm going to try something else. Ready? What I'm going to do is I'm going to take this cart and I'm going to speed it up with my hand, and then I'm going to let go and let it move this way. Let it move to the right. So speed it up, let it move to the right. When I let go, I want you to predict what the cart's going to do. Now remember, I've still got 3 newtons of weight pulling this way and 2 newtons pulling that way. So I'm going to speed it up and let go, and it's going to move this way, after I let go. I want you to tell me, is it going to speed up, is it going to slow down, or is it going to move with constant speed? So do the same thing, predict what the velocity time graph will look like after I let go. Go ahead and pause the video and predict what the velocity time graph of this cart will look like after I push it to the right and let go. Here's our handy velocity time graph yet again. So let's see, after I push the cart to the right and let go, does it speed up, slow down, or move with constant speed? Well, looky there, it slows down as it moves to the right. Is that what you thought? Well, doesn't that make sense? Because we know that when I let go of the cart, the left forces are greater than the right forces. So net force is which direction? Left. So acceleration is which direction? Left. Well, the cart's moving to the right, but its acceleration is to the left. So what's going to happen? It's going to slow down, because net force and acceleration are in the opposite direction of motion. It slows down. But what's going to happen after that? You're a bright physics student. I bet you could figure it out. Well, it's actually the same thing as the last example we looked at. After the cart comes to a stop, what's it going to do? It's going to speed up back to the left, because now net force and acceleration are going to be in the direction of motion. So watch the whole video. Now we see the whole picture. At first, the cart slows down to the right because the net force is in the opposite direction of motion. And then, after it comes to a rest, it speeds up the opposite direction because the net force is in the direction of motion. Slows down to the right, speeds up to the left. You might be wondering, hey, wait a second. Well, what about this part at the very beginning? Doesn't the cart speed up there? It gets further from a speed of 0, and it's below, so it's speeding up towards the detector. Well, look at the beginning of the video. That's just me pushing it with my hand. I sped it up when I pushed it. But once I let go is the blue part of the graph where it's slowing down towards the detector. And then, like we said, it speeds up away, and then that end part where it dips back down, what's that represent? Well, that's when I catch it with my hand. There you go. And you can't see in the video, but it bounces a little bit, which is why it does this weird thing at the end. But at the end, it will come to rest at a speed of 0. Way to go! Once you've done that and finished that sheet, you've completed all of level 1. You're ready to move on to level 2, which means now we understand why objects speed up and slow down. It's because of unbalanced forces. So once we go to level 2, the real fun begins. See you next time. From the bunker, this is Mr. Voppel. Bye. Yes. Hey everybody, Mr. Voppel here.